been working on those things since. Today is here to talk to us about wheat diseases for our environments, and I'll turn it over to Andrew. Thank you.
Okay, how's everybody doing? Everybody had a good lunch? Yeah? Is everybody going to stay awake? That's the next question I usually have to ask. Try, I like that. So I have to ask myself is, I know last year was dry, and it usually was an insect year, so why are you bringing a plant pathologist out here, right? That's always a common question. Usually we see dry weather, we don't think about diseases. So I had to change my perspective on this talk. One is, I can find a disease in every environment in North Dakota, okay? So I'm just going to make you aware of that. But really the focus of my talk is going to be on the last two, and is more of what can we expect for 2022. And then the question that I've been getting the most right now is fungicide decisions. Should I spray? What can I expect? What are some of the factors that go into that? So my goal is going to be focused more on a perspective of what about next year. And I think that's always something I try to do in most of my talks. So the one wheat disease that I can say that was more frequent than last year are root rots. Now when you think of wheat root rots in the state, there's a couple factors that contribute to them. They're more frequent when it's hot and dry, and oftentimes we have a couple of them that can infect the same plant. So why are they more frequent when it's hot and dry? Well, these are not very good pathogens in the wheat world. They need a little bit of help. When you start getting a stressed plant, that's more of their opportunity to move in and start killing it. So how I look at it is the primary problem was the lack of moisture, and the one that kind of finished off the plant was maybe a root rot. Okay, does that kind of make sense in those perspectives? The other thing that I want to mention with root rots is we generally don't see them until later on in the season. And this is oftentimes we'll see it at when it's headed out into the later stages of flowering, because these are slow colonizers. I look at it as like a vice grip. The more you squeeze it on a wheat plant, the less vascular tissue function in that plant, and then you get an empty head. And when we look at it in a field, we start seeing blank spots in the field, or what is more commonly observed like last year, is you see these little pockets of white heads just showing up. Some cases you might think it could be weather related, some other causes of white heads, wheat stem maggot, but really what separates this out is you'll see a group of plants in the tillers, and they'll just be spaced out here and there. And if you pull up on those plants, one thing you'll notice is they'll pull directly out of the ground. The root structure won't be there. They're going to have a brown lesion on the bottom of the base of the plant, and that more or less will separate it from anything else that might be causing a white head. Now, do I worry about root rots? I've had situations in the years where it was a pretty big concern in a field, but in most cases, we are trained as adults to spot the one thing that doesn't fit in a field. So if you see a white head in a field, do we focus more on that white head or about the 100 to 200 plants that look perfectly fine around it? So the question I get, what is the yield loss potential? On the situation like last year, in most cases it was pretty minor. You lose a plant here and there, but the one great thing about a wheat crop is we have plenty of plants out there to compensate, and if you lose your next door neighbor in the wheat world, you have some compensation occurring. So there are much bigger issues that I worry about in the wheat world, but it's more of an observation that I wanted to bring up. But because we saw root rots, questions are, what can I do next year from a management perspective? The first one, crop rotation. I think just about any plant pathologist is going to say crop rotation and more crop rotation. That is more of trying to manage the pathogen that's in the soil. So that can help some. One question I got last year is, do we have anything resistant to root rots in the spring wheat in the breeding program? And there's no formal screening effort. There have been some what I call side projects where they've taken a few varieties more or less to look at some more of the pathology related principles. And the best I can interpret the data is there's nothing immune, and there are some subtle differences. Now, are those differences enough to justify host resistance? From my eyes, I don't think we have it. So in most cases, I say host resistance may help, but it's not something that we should rely on. The most popular question last summer is, but I used a fungicide seed treatment. Why am I getting a root rot problem? So I'm going to dive into that data a little bit more, but one thing I always start out with is when you have a fungicide seed treatment, it's early season protection. You might get 14 days, 21 days, but as that plant keeps growing, you're going to lose that residual, I call effective residual, from a fungicide seed treatment. So the goal of those seed treatments is to get it up and out of the ground. Hopefully it develops a root system, and that alone is going to help reduce some of the issues with root rots. So when I was preparing this talk, when I talk about fungicide seed treatments, I get asked what to use and what can I expect. So the first question I'm going to mention is what to use. Now, in North Dakota, the primary root rot diseases we have are ones that are Pythium, so think cool, wet soils. The ones that we generally see every year, and a little bit more last year, the ones caused by Fusarium crown rot, and common root rot. And then once in a while, we might see take-all. That's more of under an irrigated system. They're more water-loving. But what I'm trying to get across here is we have plenty of seed treatment options. We have them in the fungicide guide that you can look at each year, but there's a couple things you need to focus on. So if I'm just going to use Fusarium and common root rot as my goal here, understanding that like your metalaxyl and mefenoxam, which is commonly used in all seed treatments, does not work on Fusarium or common root rot, but they are still very good for Pythium. But as you incorporate another type of fungicide, either from a FRAC 3, 7, or 11, you think triazole, strobilurins, SDHI, all of them have some suppression ability. Notice that in most cases, you're not going to get effective control. It's more of a suppression-based type of strategy. So when I look at new fungicide seed treatments come out, broad spectrum are often our best bet. So if you have metalaxyl mefenoxam for an early season Pythium, and if you have at least one more active ingredient to help with those other ones, that's kind of what the goal of it in this case. So what can I expect from a fungicide seed treatment? So I just showed you what can be done and what I can show you in laboratory settings, that if I place the pathogen right next to these treated seeds, I can show you what's working and what's not working. But what about in field plots? What are we seeing out there in general North Dakota? So I went to a very large data set because in my program, we do fungicide seed treatment work every year. And I can probably the last 3 to 5 years, or even the last 10 years, you're going to see different responses. So my goal is when I start looking at all this data is I wanted to look if there was a difference between eastern and western North Dakota. And more importantly, what are we looking at as far as a stand response? Does it always improve stand? What is the general trend that we see with fungicide seed treatments? So the data set I'm working with is I went back to 2003, which was, for me, a long time ago, but 2003 to 2020, and I summarize all this data. And I try to make sense of it, right? There's a lot of different factors. The two things that were consistent, though, is there was trials done in Dickinson and trials done in Fargo. So that was the only east-west comparison I could have with this big, large data set. I looked at what was the general response, and then I even broke it down by if there was one mode of action that was better than the rest. Okay, so everybody still with me? I know this is a big, long preamble on this, but just bear with me. There is a pretty good story with this. So if I looked at every treatment that I have, and I put it on a bar chart, this was the response. So for some of you that aren't going to see that, this is probably pretty typical what I would expect from seed treatment work. You had some cases where it responded very favorably, and in some cases we saw little to no response. But on average, about an 8% increase in stand, okay? So that's how I look at it from a fungicide seed treatment, that out of those 46 experiments across 2 environments, we saw a favorable response, about 8% of the plants that were doing well. But the next couple questions is, does it matter if it's a location or about the mode of action? So if you look at the difference between an east and west response, the expected stand increase that you may see was fairly consistent in both eastern and western North Dakota, meaning that if our average was at 8.4, you could kind of see that we're ranging from 8 to 10%, depending on western or eastern North Dakota. And then finally, if we look at the FRAC groups, I didn't see much differences, whether if you had one fungicide seed treatment or multiple, the response was doing very well. So if I was to package this into one thing, I could say that seed treatments usually provide a favorable stand response across multiple environments in North Dakota. But this gave me one more thing to look at, and I got asked this question last year, I think, was do soil conditions matter? When you think cool, wet soils, which we always have each year when we're planting, do we see a bigger response in that versus if it's warm and dry, warm and wet? So I tried to add some weather variables into this, and what I looked at was soil temperature, and the best estimate I could get for any type of moisture patterns in those environments was the rainfall 7 days before and 7 days after planting. Okay, not a perfect measure of moisture because I wasn't able to get what did we have coming into the season, right? I didn't have the data for that. So I tried to draw this onto looking at these two factors of temperature and moisture, and what I found that in the upper right-hand quadrant would be a higher stand response and a higher yield associated with it. The bottom corner, our left-hand corners, be lower yield and lower stand response. So what am I looking at? Size of the circle indicates how much moisture. Color is looking at what the temperature gradients were. And it came messy, meaning that I didn't see a trend. I'm not going to dive too much into this, but whether if it was a wet and cool or hot and dry, there was no correlation, meaning that you got a better response every time in this type of soil conditions. So the add-on from this project of what we're trying to do now is I'm starting to establish more trials, more uniform trials, trying to reduce some of these variables to see if I can fine-tune this response a little bit more. So again, seed treatments, they can help with early season protection. They're really good for seed-borne diseases, but what we saw with root rot issues last year probably aren't going to contribute much to that. But I thought it was a good opportunity just to talk about fungicide seed treatments in general. Okay, is everybody good with that first third of the talk? All right, I still see most eyes open, so we're okay, we're good. All right, so the next question I want to talk about was the common statement is 2021 was dry. What can we expect for 2022? So what this would lead to is we had less diseases and thinking that we have less pathogen pressure moving into 2022. And I think from a general perspective, that is true. You're maybe not going to have as much as what happened in 2015, or maybe in 2019 in some areas, right? But there are three things that I always want to mention that even coming out of a dry year is we should avoid a short-term memory of what happened last year with diseases, because I know pathogens survive very well in this state. We're always going to have them around. They're conditioned to survive dry, they're conditioned to survive cold weather. They are survivalists. And finally, we know that weather drives disease, but more importantly, weather during the season, what's going to drive our disease epidemics. So what are some examples of this? I'll just like to show you. And I know we can't compare 2021 perfectly to any other year, but I talked to Daryl Richardson and I asked him, I said, can we compare 2017 and 2021 as far as two environments and what happened to some of the diseases the following year? So he gave me two rainfall maps. Again, this is from 2017 and 2021. The big thing is he said they're probably fairly consistent, not exact measurements, but I'd consider both to be very dry years. So how did that impact diseases? So the two diseases I'm going to mention is bacterial leaf streak, a foliar disease, residue and seed-borne disease, something that loves water and something that loves rainstorms, okay? So the best data set I could pull from is each year we have an NDSU IPM survey. I know TJ and Jan have talked about this. Audrey helps out a lot here out at the Williston Center when it comes to coordinating this effort. And I started looking at what was the percentage of fields with bacterial leaf streak from 2015 to 2021. And what I was looking at specifically is when those fields are scouted between flag leaf to some of the flowering stages, because that's when we usually see this disease. So what did we find out? So I want to draw your attention to 2017. Our scouts found bacterial leaf streak in 0% of the fields, 0. What happened the next 3 years? We had quite a bit of bacterial leaf streak in the state. So what was driving that? Could be some seed issues, but if I had to put money on any type of parameter when it comes to diseases, the weather during the growing season was a big driver of why we saw some of that, okay? There are some host resistance things too that could contribute to it, but the big picture is here is we came out of 2017 not expecting much, and we had quite a bit of bacterial leaf streak. Let's switch diseases. What about a fungal disease? Fusarium head blight. Anybody still remember Fusarium head blight? Audrey, I think you still have nightmares about it? Okay, maybe, anyway. What happened to Fusarium head blight in those same years? And again, I only picked the fields that were scouted when we can actually find Fusarium head blight out there. You're going to see a pretty strong story here, right? Meaning that the year coming out of 2017, And this is across the entire state. I could break this down in the region, but in each region of the state, you saw more scab the year following after a dry year. And it wasn't because it was dry before, is that as soon as you get into that growing season, those conditions change. You're going to see rain and humidity that's going to be fluctuating, and sometimes that's going to promote disease development and not promote it. So my big picture is like, is it possible that we have zero disease issues next year? Maybe. Am I hoping for a bigger yielding crop next year? Yep. So if that means we have a bigger yielding crop, that means we have more moisture, we might see some more diseases. How much? To what extent? I don't know. I mean, I'll be honest and tell you. But there are some things I just want to remind that we just still need to think about the growing season and what's occurring each time, especially with disease management. So what do I expect? I always start is understand that variety, know what's in that disease package, which ones that you're more familiar with. If you've had issues with tan spot every year, understand that they're going to be there. If you have some potential worries about Fusarium head blight, understand how much resistance you have to that. It's just good to have a standard in that level, because that's going to help to decide on some of the decisions, such as fungicides. It's going to help you understand what we can think about in terms of just general management practices in general. Now, there are going to be a couple difficult situations. Been handling calls on putting wheat on wheat ground again because of excess fertilizer, some of those decisions, and in those cases you might just have to be a little bit more aggressive in some cases as far as when we look at disease management. So does anybody think that's an okay 2022 prediction? Is that good enough? Yeah? Okay. So the last third of this talk is something that I think I've gotten most of my requests this year when talking across the state is about fungicide decisions. And it comes down to when to spray, what to spray, this is my situation. And depending where I'm at, my answer might change a little bit, okay? So I try to give you more of a big picture perspective of what I think about as that decision to make a fungicide. I won't be able to go into the dollar values amount or maybe some of the potential shortages in some of the certain products. We're still trying to get a feel for that in the fungicide market right now. But I'm just going to talk in terms of disease risk. And secondly, I'm going to rely on the data. It's somebody that I like taking. We have a treasure trove of field data out there at NDSU, and I like building all this data together to help present some trends. So the first question I wanted to address is, what is the expected response from a fungicide depending on a disease environment? So again, going back to a big data set, 2008 to 2021, and here we had I'd say a variable amounts of fungal leaf spots. You had some rust diseases. That's a big year, right? A big year gap. So we're going to have some issues being more prevalent than others. But there's a couple things that I was able to pull out of there. One, I was looking at what was the value of that tillering application or that herbicide pass application, and what was the value of a flag leaf fungicide application in what I call 4 disease risk environments, okay? Not everything is created equal in the fungicide world. Your response of a fungicide is going to depend on what do you have currently going on in the growing season. So what I did is I'm looking at the percent yield response, because that oftentimes is what's going to bring up some of the attention getting data. And before I get to the yield response, I want to explain the 4 disease risk categories I had. So the thing I looked at specifically was the susceptibility of a variety. I looked at what was the previous crop, type of tillage, general perception of rainfall and dew periods, when disease came into the plots, and how much occurred. So I tried to make this as robust as possible, but really it came down to 4 categories, and they were very low, low, moderate, and high. And the things that really kind of drove most of the diseases was what variety was planted and what was the previous crop, okay? And in most cases, it was the variety planted. The more susceptible a variety, the higher the disease risk, and it's going to be the higher response. So let's jump into the data here a little bit and looking at how well did a tillering and a flag leaf fungicide did for yield response. So here we're looking at percent response. The higher the value, the more percent. To help kind of apply this into a general production system, I'll just use a 50 bushel expected wheat crop, okay? So if you look at that tillering application, probably nothing revolutionary. As our disease risk got higher, we saw a bigger response. In that low to moderate, if you want to talk on a 50 bushel crop, it's about a 1 to 2 bushel type of response to it. Okay, so again, a higher disease risk, meaning that if you have a susceptible variety and you're in a short rotation away from wheat, or you have those things that contribute to some of the fungal leaf spot pressure, you're probably going to pay for that fungicide depending on the market. What did we see from a flag leaf fungicide? When it comes to a flag leaf fungicide, probably our least popular fungicide option in the state, and oftentimes when it's going to pay is when we have rust diseases, or we have a management situation of not controlling fungal leaf spots early in the season. So if you want to look at that very high disease risk situation of 19% yield response from an application, most of that data came from a year we had a high level of stripe rust in the state. And the one time that you can manage that is at flag leaf. So that value is a little bit inflated, but the same general trend is, you know, even if you did spray fungicide last year, what did you expect? I always say fungicides are best used when they're integrated with host resistance and when you have disease as a problem. Applying a fungicide in a low disease environment, on average, it's going to be tough to pencil that out. The only time that you might be able to do that is maybe in that early herbicide pass, but at the same time, different production system, how much emphasis, how much cost goes into that, that's going to vary. That's going to vary by producer. So once I got done with the fungicide timing, what if I used, did the response and yield differ depending on what fungicide I used? So again, looking at some data across North Dakota and into Montana, I worked with Mary Burrows out of Montana State. Basically, she sent me all of her hard red winter wheat data where she had 0 disease in the plots, and I combined it with all the hard red spring wheat data where I had 0 disease in the plot, and we wanted to look at to see if the response from a fungicide, either a QOI or strobilurin, or think like the products in Headline and then Quadris, compared to some of the triazoles, so think like Tilt, Folicure, those triazoles, and then some of these premixes out there. So if it's Quilt, if it's Priaxor, more or less is this, would your response change if you changed your fungicide in a low disease environment? So combined all the data, went through the analysis, and this is what it looked like at the end. Now this is talking in bushels per acre. So regardless of what fungicide was chosen, in a low disease environment, when you don't have disease as an issue, our range of response is 0.4 bushels per acre to a bushel per acre, okay? So kind of keep those values in your head. When we start thinking about fungicide decisions in low disease environments, I think this is pretty consistent with what we see in wheat, what we have seen in soybeans, what we have seen in corn, is that you're sometimes going to be difficult to recover some of that cost, okay? So who's tired talking about fungicides in low disease environments right now? Well, guess what? I got one more data set for you to really try to bring this all together, because we have another application timing for Fusarium head blight, right? So what did that do last year? So when we're spraying for low scab risk, this is a little bit more difficult to obtain in my program. So this is this trial that we did last year, and just to kind of give you an idea of what we do at NDSU is through the U.S. Wheat and Barley Scab Initiative, we get funding to run Fusarium head blight trials and fungicide. I work with Audrey and Tyler out here. I work with the folks at Langdon and in Carrington, and then starting Minot next year, and we have Fargo. So my goal is to throw as many trials as we can out there and to evaluate all the fungicides we have for scab and just get this nice big data set. Okay, so last year in spring wheat data, most of our trials were low disease risk. The 3 that I'm combining data for today are in Carrington, Fargo, and Langdon. The thing about Carrington and Langdon, they're under irrigated environments. My Fargo environment was under dryland. Here we had 4 varieties we looked at, and more or less the treatments that we were paying attention to were Miravis Ace applied at half head, and then early flowering, or that recommended scab timing for Presaro, Carumba, Miravis Ace, and then Spherex, which is a new fungicide for scab that I'll talk about here a little bit. So what did we see from a yield perspective in these low disease environments? If we look across the board compared to the non-treated check, we saw what I call a significant response from a fungicide under low disease risk for scab. But there's a catch to this. I wanted to kind of highlight that at Carrington and in Langdon, this was under irrigated. And in those cases, we did have a high level of foliar diseases on the flag leaf. The problem is we didn't rate them. So I can't really contribute that all this fungicide response is due to protecting the plant at the flowering. It likely had to do with protecting some of the flag leaf that you can get in late season control. So on average, how do I interpret this data? Under a low scab risk, if you were to spray a fungicide, it'd be difficult to recover the cost in a dry land environment. Because if I single out the Fargo location in this, the response from a fungicide varied from 1 to 3 bushels. Okay, some years that might work, but in most cases, I like to see the judicious use of fungicides and kind of preserve some of the tools we have. Now, if you use a mildly resistant variety, that response goes down probably a little bit more than that. So, again, I hope I was able to convey just a little bit of my fungicide ideas in these low scab and these low disease environments, but it's kind of important to go back to the data and also understand some of the things we'll be facing next year. So I want to end this talk, and I might be running short today, but usually that's it's not something that is brought up too often as being a bad thing, is I just want to end on some of the Fusarium head blight practices, or what I call my little remembrance notes of what we need to think about next year. So for scab, first and foremost, variety resistance is our best tool. That is what I say is going to give us a leg up on the Fusarium competition. When I look at Fusarium resistance, I consider that it's going to reduce your risk by half. Okay, everything in the scab world I feel is like by half. There's nothing out there that's immune, nothing that's going to be a silver bullet, but we can always just keep kicking down the management suppression a little bit more. For fungicides right now, as I say, as of last year, we have a couple different products out there. If you want me to rate how these fungicides perform, I consider Carumba, Prosaro, Miravis Ace, and Proline all to be good fungicide products. Your Folicare and Tebuconazole generics, they're fair. If you want to talk about suppression of what they will offer you, the good products will give you 50 to 60% suppression. The Folicare generics, maybe around 20 to 25%. So there is a little bit of a cost when it comes to using a fungicide. So that is what I look at it. And if I were to say, if we ever have a product that would be excellent, that would be something called 100% control, which logistically, I don't know if we'll ever get there because of timing issues, but that's just something to kind of keep in mind. The other thing is, regardless of the fungicide the fungicide that is chosen, our data shows that the best time to apply is at early flowering, and you have a window of about 7 days to make an effective application. So how I look at it is you have 7 days to make a good fungicide application for scab. Okay, doesn't matter what product you use. That is where the best time is to make that timing. It's very different from when I started my position 10 years ago, where we thought we had a much narrower window. So I think that we just have data now to show that we can reduce scab and we could reduce the DON in the fungicide itself. And the new developments in the fungicide world is there are 2 new fungicides coming for scab in 2022. One is called Prosaro Pro through Bayer, and the other one is Spherix, which is out of BASF. So to kind of break these down and what these look like, there are no new active ingredients out there that are in these products. What it is it's a repackaging of some of the more effective ones. For Prosaro Pro, you're going to start out with your prothioconazole and tebuconazole. That's the base of Prosaro. And the addition to this is fluopyram. Now, fluopyram is an SDHI, so it's not a triazole, and it was initially brought in through the seed treatment world to handle some Fusarium diseases on soybean. Okay, so it did have some soybean activity, and now they're bringing it into the scab world. Spherix is taking more or less your most effective triazoles, metconazole, which would be in Carumba, and prothioconazole, which is one component of Prosaro, and merging them together. So now you have what I call our two most effective triazoles in a new formulated product. So the question is how do they look? So going back to some of the U.S. Scab Initiative data that we've had, you can see in our data that both Prosaro Pro and Spherix will be good products on the market. They're going to be very similar to what we already have, but it is just 2 more options out there for it. So we have a more extensive look at these fungicides in the coming year. But just wanted to kind of bring this up is that you might be seeing this in the next couple months here as far as what's going to be available out there. Now, don't ask me on costs, because I couldn't tell you what the cost is going to be. I can always say it's going to be somewhere between $0 and $20. Pretty good, right? Yeah, that's a safe bet, obviously, but I know there's going to be a lot of factors that go into it as far as what that cost is going to be. So what are some of my take-home messages today? Wanted to let you understand that we still can get we can get diseases during a dry year, but they're not as significant as what we have with some of these water-loving diseases that we have in the state. Avoid short-term memory with diseases. And I know it sounds a little bit like I'm beating on this topic a little bit, but I know how pathogens have worked in the state. We have some great survivalists. They're here. They're more or less waiting for that right weather to make their ugly head appear again. When it comes to next year's decisions, I always say understand what variety you have and then layer what you're already using. If you're using crop rotation, in some cases, not always, there might be some tillage in play, and then look at where those fungicides fit into that component, right? Are you going to need them? What can you start kind of categorizing those fields that may have more or less disease risk? And then fungicides should never be relied on, what I call in term increasing yield during dry years. We see some positive trends, but sometimes I don't think they're going to pencil out. And if I'm in the long run, it's not something that I think is going to be what I call a viable option if you continue to use fungicides in dry year. It's going to be tough to make that work. So that was my presentation. And my favorite parts are questions. Anything I didn't cover, and anything else you want me to just think big on? I mean, I like everything, except insects.
Selectively applying for scab by elevation on your fields.
Okay, this is a new one for me. Okay, so the question is selectively applying a fungicide for scab based on elevation. So high points, low points. Okay, so if I'm looking at a field, and if I'm looking at an environment, generally in the lower parts of the field, higher water, potential higher retention, potentially higher humidity, those would be the areas that would be at most risk for scab. So if you're doing a selective process, that might be something you might prioritize. The more you move up into an elevation change, more frequently it dries out. And one thing that scab absolutely loves is relative humidity or less dew points. So anything you see that is where I would think I would focus. The only exception is if you're along tree rows. When you think about tree rows, a lot of times when I'm scouting fields, I go right to the tree rows. And the biggest reason why is I know oftentimes there's a little bit higher moisture retention or relative humidity. So if I know if there's a disease issue, it's probably going to be the highest in the environment where it likes, and it's probably going to progressively get less in the field. So there's my little curveball on top of that. But for the most part, the lower part of the field is where it would be a priority for something like that. I like that question. I'm going to add that to my toolbox. Anything else? How about this? Who sprayed a fungicide last year on their wheat? 1, 2. I mean, I see a whole bunch of hands over here. I just won't single you guys out. That's fine. No. Can I ask you, is just something that you just always done, or just worry about what happened in previous years? Or was it a location base? Irrigated. Okay, I should have said who sprayed a fungicide on dry land. I got tricked into that. That's my fault. I walked right into that one. Yes, water, moisture, got it. I agree. Anything else? Okay, thanks for your attention.